So question 15, we've got z is r cis theta be a complex number where the argument is somewhere between pi by 2 and pi, which is a little bit unusual, but anyway, express in terms of r and theta this complex number. So on the formula sheet, we know that the conjugate of z is r cis negative theta, and when we divide, obviously here's how to do it. It's the we divide the modulus and subtract the arguments, but the only tricky thing for the 3 marks might be working out negative root 2i plus 1. If you wanted to use your calculator because you are feeling a bit lazy, then we could do this. So we'd have a negative root 2, what was it, brackets, so then if we come out I plus 1, so shift dot plus 1, press go, and then action complex to trig form, and poof, there it is, 2 cis negative 3 pi by 4. But anyway, we've done that over here, 2 cis negative 3 pi by 4. So all that's left is basically it's going to be r over 2, and then cis, so it's minus theta upstairs, so that stays, but because we're subtracting minus 3 pi on 4, then that becomes positive. So there's the first 3 marks. Then over the page, and this question has a massive amount of space. I'm not really sure why, because we needed about 2 lines for the first 3, and we only really need a couple of lines for the part B. But anyway, maybe it's to kind of keep this question earlier in the piece, because we've got a whole load of 2 pages coming. Anyway, express alpha is arg z minus ri in terms of theta, and we kind of think, is there a connection between this part and part A? It doesn't seem to be. If we sketch z minus ri, and we know that from part A, z, the argument is somewhere between pi by 2 and pi, so we're in the second quadrant over here. So my little sketch here, I've got z going up into the second quadrant, and then we add to it negative ri, so r is going to be the same length as z, but it's going to be going straight down in the negative I direction. So we've got ourselves a little isosceles triangle here. I put in some angles, the red dot at the top and then 2 blue dots, which I've called beta, at the bottom. You could also create a parallelogram here, which is going to be, or even a rhombus, isn't it? Because all the sides will be the same. Anyhow, to actually get the argument, so we want the argument of this green line, which is the sum of z minus ri here. We're told that we actually want it between 0 and 2 pi, so we're measuring anti-clockwise from the x-axis around here. So basically we want theta plus whatever this little blue dot is. Now, if you look at the whole picture here, theta plus 2 blue dots, so 2 beta, is going to be 3 pi by 2. So we know that 2 beta is 3 pi on 2 minus theta. And then we want to add theta and beta together to get our angle. So here we go. It's theta plus, now beta, meanwhile, is going to be a half of this. So that'll be a 3 pi on 4 minus a theta on 2 for half of this. And when we do that, we get theta on 2 plus 3 pi by 4. And then you kind of see the 3 pi by 4 here, and sort of that was part of the answer to part A, and you think, did I miss something? But it didn't take us long, so we're not that worried.